All right, question number 10. We want to evaluate the following limit. The limit of the polynomial 3x to the 8th power minus 4x to the 3rd minus 1 as x goes to 0. And this is raised to the 37th power. All right, so the first thing we're going to do is use direct substitution and see if we can evaluate it. So plugging in 0 for x. So we're plugging in 0 for 3 times 0 raised to the 8th power, and then 4 times 0 raised to the 3rd, minus 1 raised to the 37th power. So anytime we multiply by 0 or raise 0 to a power, we just multiply multiple zeros. So this term goes to 0. This minus 4 times x raised to the 3rd goes to 0, just leaving us with a negative 1. So we have a negative 1 raised to the 37th power. So that's multiplying negative 1 37 times. Since that's an odd number, that means we're going to have an odd number of negatives, and multiplying 1 repeatedly just leaves us with 1. So this will just end up being a negative 1. All right, number 11. It says suppose f of x is defined as below, and we're going to use the continuity checklist to show that f is not continuous at 3, and then if it says is f continuous from left or right at 3, and then we're going to state intervals of continuity. So we have a piecewise function. F of x is equal to x squared plus 3x, and that is from x greater than or equal to 3. So that's 3 and above, and then we use the function 4x whenever x is less than 3. So rough sketch, we would have a linear function, and 4 times 3 would give us 12. So let's say that this is 12 when we get to 3. 1, 2, 3. So our graph would have an open circle, and it would be a linear function kind of going down like this, 3 and beyond. And then depending on where the center of our parabola is, starting at 3, if we plugged in a 3 squared would give us 9, and then 9, and then 3 times 3 is also 9. 9 plus 9 gives us 18. So if this is 12, our next parabola would start at 18, and depending on what part of it, the parabola would be curving up. It'd be a whole point, and it would be just curving up from there. So it's a big gap. So when we look at the limit as we approach 3, there's a jump, there's a gap. These two numbers aren't equal. So the limit does not exist. And it's not because f of 3 is not defined, because we plug 3 into both, and this is the one where we actually use 3 because of the equal to. That's why we have the closed circle. 3 is defined, and it is 18. So it's not because it's not defined. It's because the limit does not exist, and the limit does not exist because the left and the right go to different points. Alright, so now part B says, is f continuous from the left or the right? Okay, so that means as I go from the left side, going toward 3, we end up at an open circle, so it's not continuous because we don't reach that point. We just get ever so close to it. But as we come from the right, going toward 3, we end at a finite point. So it is right continuous, continuous as we come from right to left. And then C, what are the intervals of continuity? So you're just using your restrictions here. So this one is saying less than 3. So if you think about a number line, usually when your variable's on the left-hand side, this inequality symbol points you in the right direction. So from 3, let's say this is 0, and this is 3. So from 3, we would have an open circle, and we would be going this direction all the way to negative infinity. So we have this interval negative infinity up to 3, both parentheses. And then when this function is used, we would include 3, and then we would go everywhere this direction all the way to positive infinity. So the next interval would be a bracket because of equal to 3 all the way up to positive infinity.